Hello everybody, and welcome to part 14 of my FTC programming tutorial videos. This video is just going to be a high-level overview of what an autonomous program looks like, and I'll start to talk about different ways that you can go about controlling your robot in autonomous. So, getting started with just the high-level overview, this is an autonomous program that I wrote, and all it does is it sets all of the drive motors to half power, and it allows them to run for half a second before stopping the program. So if you look at this, there's only a few things that are going to be different from a teleop program. The very first thing that's obviously going to be different is this autonomous tag. This differs from the teleop tag, so this autonomous tag is just going to put it in the group of autonomous programs. The next thing that's going to be different is instead of having a loop after wait for start, we're actually going to have just a linear sequence of instructions. So in this particular case, there's no while op mode is active loop. There's just a list of instructions with pauses in between each one. So this is a very basic program. All it does is it sets all the powers of all of the drive motors to 0.5, and then it pauses for half a second. Now, using sleep is not the best way of doing this. There are other ways of doing this, but this is kind of what I would recommend to just kind of get started. Now, you can do this for the entirety of your autonomous program if you want. You can do everything based off of timings, and you can have a fair amount of success doing very, very, very basic driving sequences in autonomous. So, for example, last year on 4097, our auto park program for meet 1, 2, 3, and maybe 4 was run off of timings, and I believe we had a very high rate of success with getting those autonomous points for the parking stage of the game. Now, the downside of using timings in this way, especially with sleep, although this also can happen with elapsed time and total runtime, which is something I will talk about in the next video, is it's going to differ depending on how much voltage your battery is currently putting out. So a little piece of advice is when you set the power of your motor, you're not setting the velocity or RPM of it. You're setting a voltage to it, and the voltage is going to depend slightly on how charged your battery is. So in this particular program, if I have a fully charged battery and it's putting out 14 volts and I set all these motor powers to 0.5 and then I sleep for half a second, it could go pretty far. Now, if I have a weaker battery that's maybe only putting out 8 volts and I do the same thing, this robot is not going to go nearly as far. That's something you need to keep in mind when you're configuring timings like this. Now, the way to get around this is to use an autonomous localization system like Roadrunner, which is something that I believe I'll be talking about in the future, or you can do something with motor encoders and relying on the exact position of your motor. So instead of driving forward for half a second, you'll drive forward 5 full rotations of all of your drive motors. The other way that you can go about doing this is using a finite state machine. Now, all a finite state machine is going to do is it's going to allow other things in your program to run while you're waiting for this action to finish. So this is something that, again, I'll talk about in a future video, but just so you can kind of get introduced to the concept, if you had a motor encoder and you needed your motor encoder to be running, this sleep function is going to stop your motor from holding a specific position. So let's say you have an arm that's holding up a game element and you start to drive forward and you call this sleep function. Your drive motors are going to keep going, but the closed loop control as part of your arm is going to stop working. And the reason for that is because the program isn't looping anymore. The entire program has halted at line 26 until it's done with the 500 milliseconds. So a finite state machine is just running your entire autonomous mode based off of timings, but throughout different states. So you'll kind of plan it out so that you'll have a drive forward state, a pause state, a turn left state, drive forward state, so on and so forth. And that just allows everything else in your program to continue running. In that particular case, you will find that you will have a while op mode is active loop running in your program. Although we're going to be using a switch statement, and we're just going to go run back over the same lines of code over and over again. All right, so I hope this video was helpful. If you have any other questions regarding autonomous, please let me know. I'll be making more videos on this topic, although autonomous gets pretty deep in the weeds on some of these things. There's no one right way to do it. I'll talk about the finite state machine running based off of timings, running based off of total elapsed time, driving based off of motor encoders, and I will also talk about Roadrunner and running FTC lib and a command-based autonomous. All right, if I can help with anything else, let me know. Otherwise, I will see you in the next video.